Well, we're really close to the end of the course now. And I'm going to take a moment to not do a numerical example, but to highlight something related to this second type of surface integral for flux. Now, for those watching, I sent my own students to go search around or view some other people's material on what flux is. Just frankly, my limited graphing abilities and drawing abilities fall well short of what would be a good idea for flux. But if you want some samples, you could think of flux as there's a, well, how about rain through your jacket? And perhaps if the rain falls heavier with more velocity, it passes through differently. Does your jacket keep the water out? Or you could look at it as maybe light passing through a window, or that superhero with the big S on his chest. How much of that radiation goes through a lead container? The rain, the light, the radiation, the wind through your jacket, those would be represented by a vector field in 3 dimensions. And then the n is the normal vector to your actual surface. And so if we look at the pieces of this puzzle, we have the vector field So the question is how much of the vector field actually passes through the surface? And the theory behind this, the proof of it, is quite difficult, but the concept I don't think is as scary as I used to think it was when I was in my earlier years teaching. But you're going to find out you've forgotten some things from earlier in the semester right now. So we've got a vector field dot product, this capital N. Now this capital N happens to represent a unit vector. Happens to represent a unit vector. Now this can be done in the XYZ or rectangular form, or it could be done in parametric form. I'm going to show rectangular only. And if you've been watching my more recent clips in terms of the where they place in the series, then you'll know that I've shown you that the surface z equals g of xy, we could create that normal vector by writing this as a capital G. Anyway, I created a lowercase normal vector. Now, some books and some instructors might reverse the letter roll here. I'll show you why I use this momentarily. And one possible notation for this, again, this is from a previous segment, I'm showing you this, is write it this way. We called the capital N the principal unit normal vector earlier in the semester. So I want to use the capital N again for a unit vector. And to calculate a unit vector, well, we would just take our vector that we have here and divide it by the magnitude, which would be this very familiar expression. Now, if we put all the pieces together and realize d with respect to the surface also has that same magnitude expression in it, this formula can be algebraically reduced to something, I would say this is not quite the formula that you could plug into a calculating device and evaluate. It's a notational representation of adding up some quantities. The only thing I want to do before I show you the magic formula is basically talk about this little dot product here. If you took a vector f and projected it onto a unit vector, the dot product was the actual length of that projection. So the projection might look like this. Earlier in the course, remember what I said? Some things that you might not have thought about for a while. Remember what the integral does. It's an adding machine. What we're about to find out is how much of this vector field is, well, okay, normal to the surface or passing through the surface. So when I'm done, I'll get my flux calculation is equal to the vector field dot product. Again, some terms will be reducing the following. And now it's in proper double integral form, with one exception. The vector field may have a z in it. And do you recall where we get our z from? Well, that's right. Z is the surface, and we will temporarily substitute that in if z lives in this vector field. So only x and y will remain here. Stay tuned for videos where we evaluate it. This is just sort of again, a discussion, kind of one-sided discussion of sort of where the pieces of the surface integral for flux comes from.